Okay. First is exponent. Okay. In calculus class, I told you that about exponential, right? Um, so why it's called exponent, right? So first, why it's called the exponent? Okay. If I have this polynomial x cubed, okay, and I have 2, 3, 4x. If this is A, this is B, which one is greater in general? Okay. At some point, maybe there's some fluctuation, but in general, which one is bigger, A or B? A or B? Who's A? Who's B? No? Okay, let me show you. Because you need proof, right? Okay. Okay. Anyone have tried this website? Okay, let's just make x squared and then make 2x. And then the other one is x cubed. And I think just this 4 is enough. 3 to the x. Okay. Let me okay. See the red color is 2 with the power of x. Okay. The green one is the x squared. Okay. At some point here, the green is above the red color, right? This. Okay. But if you seek through until one point here, the red color is going above the green. Okay. And it's keeping larger the gap. What does it mean? If you remember the calculus, the tangent gradient, the gradient is getting larger and larger, right? Becoming more vertical. But the green one is a little bit more towards the horizontal, right? But the red color is going vertical. Okay. Let's try another one. I think this is quite interesting here. The red color here and the blue color here. Okay. If we go through, it's the red color above, right? It's more left, right? The red color, meaning it's faster. Get it? Get it? The red color is faster, and the blue one is towards to the right. Okay. So why it's called the exponential? Because it is faster. It will be multiplied by itself. And also, when you derive the exponent, you know that e to the x derive e to the x, right? You will multiply by itself. Or if you have 2 with the power of x, when you derive, you get that value multiplied with the logarithm. It's logarithm, okay? So that's the definition of exponential. So it will be multiplied by itself when you are looking at the gradient, okay? In every point, you will see the original equation itself, okay? Okay. I think that's enough. Okay. So clearly the P is greater than A. Okay. So exponent meaning it's multiplying or by itself. Okay, so that's why we can use this exponential to analyze populations, or if it is decreasing, you say some radioactive decay, for example. Yeah, but mostly we are using this for population because it will be getting larger. Like for example, you have two like couples, okay, and they have children. Okay, the more you have the couples, okay, the total population will getting larger and larger, okay? Like exponent. Okay? That's the population, okay, and it's in your and it is making sense, okay, it's making sense. Okay, okay, so first we need to know the exponent itself, okay. We call this the exponentiation. I believe this is all you have learned before in school, but let me just write some notes. Indices or index, okay. So you have 2, 3, okay. This means 2 and 2 and 2, right? We call this 2 is our base, and this 3 is our power. Okay. And we know that this is become 8, right? Some calculations. Okay. So if you have a m multiplied by a n, what will happen here? A m plus n. Okay. I will go very quick here. So a m divided by a n, a m minus n. Okay. And if you have a, it will be 1 over a m. Okay. I don't need to prove this. Okay. Is that okay? I think you already know, right? Okay. If I have this with the power of 0, what's the result? 1. Why? You know that it's 1, but why? I'm just asking why. Do you have some roughly proving this is 1? That's easy. Start with this. Okay. It's easy because you're just multiplying by 2, 2, 2, 2, right? It's 16, right? So it's 2 multiply here, right? Okay. But when you go up, it's divide, right? Right? So when you have this, it's divide too. Is that okay? So that's just 1. Okay. And when you have negative here, divide. Divide 2 will be half. Okay. Is that making sense? Okay. Okay. So when if you have like nephew or little brother or sister, why 2 with the power of 0 is 1, and you cannot explain it to your nephew. Okay, and now you can at least tell your nephew. Okay, and also, oh wait, if you have this, I can write this, right? Okay, that's okay. Okay, I think that's all the important things in exponentiations. Okay, I will go through the logarithm now, but if we need to go back to exponentiation, maybe solving some problems, I will add some notes later. Okay, but we just go now for logarithms. Okay, so logarithms. What is log? The definition of logarithms. Why you are doing in your high school? Oh, log 10 is 1. You know that, right? But what is logarithm? How can you explain if someone asking to you, like you have a brother, what is log? I see in your book log. What is log? Can you explain? Anyone try to answer? You, no. Why you're you're choosing your friend? Okay, okay. Uh, log. Okay, it's different perspective as we see numbers. Okay? Before you have this, right? Can I say just a conclusion? Okay, log is the inverse of exponential. So when you have a scaling, like um, like in base of 10, and then you have a database millions and millions number, it will be much easier if you convert all into log, and you will see the curve instead of trying in raw statistics. Maybe it will be, you can see something there, but when you choose the log, you will have simplify your terms, you simplify your results, and you might be able to see or you observe something that, okay, I know understand what my database means. Okay, so this is just basically the inverse of exponential. Okay, um, let me just write this, but don't memorize all the things. Okay, so a way of looking differently, yeah, differently of exponential. So this is the results. This is the exponent. This is the, how to say that, the base, or in terms of populations, this is like a growth rate. And the exponent is like a time if you compare with the populations. Okay. So I can write this as logarithm of base 2, and then the results. And then, so in exponent, we are indexing some power and see the results. In log, we want to know the exponent. Okay. So I can say that this, you can pretty much like a inverse, okay, from here to here. And we have the tools called log. So we say this logarithm um, base 2 of 8 is equal 3. Okay, very basic. So when I have log, let's say log base of 3, so log base of 3 of 81 is, yeah, 4. Okay, I believe you're already familiar with log, right? Mm, how about that? Hmm? Yeah, 6. Still confused? Okay, if you're still confused, let me explain. Okay, what is happening in log? Okay, like for example, this one. Log of 2 log base of 2 of 8 is 3. So which means I can write this as this one, right? Okay, got it? And I can rewrite this as 3, 4. Okay, so I can rewrite this as something x here is 27. Okay, and I can make the law of exponent as the beginning, 3 with the power of half, and I multiply with x. Okay, and 27 is 3 with the power of 3. Okay, so for half x is 3, so x is 6. Okay, you need to be familiar with this. If not, then your whole calculus will be in trouble. I've checked the quiz. Some of you, it's really bad. Okay, it's really bad. Some of you are not understanding the basic. So you need to taking this basic math course seriously. Okay, if you think the basic math is, some of you think it's too easy, but some of your friends think this is difficult. So let's just make balance. Okay, you need additional how to say that. If you feel that in some sections or some chapters you feel trouble, just tell me, okay, and I will review a little bit. Okay, this is how we got the x is equal to 6. How about the, let me move this to the side. How about log 6? And this is, okay. So log base of 6 of 1 over 6. Okay. I want to check all of you whether you are understand or not. What's your results? You? Okay, you really need to get the basic. How about you? Okay, good. Okay, good. Okay, good, good. Okay. 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 Please focus and concentrate. Okay, if you feel this is troubling you. Okay. So see here, it's the same as the left side. Okay. This is square root of 3. Okay. So I will just write 6 because it's the base. Okay. This is the base. This is the base. Okay. And I need to power with something. Just call it any variable, a, b, c, y. That's fine, right? And this should be resulting the 1/6. And the idea of log or in exponent is to equaling both sides. Okay, like this one, the square root of 3, you can make the square root goes here, become half, power of half, right? 3 half x. Okay, from here. 27 is 3 with the power of 3. The same thing here, 6 y, and then 6 with the power of u. How 6 with the power of y here, okay, and this 6 with the power of, huh? No, here, this 6 with the power of here. Okay, okay, here, this is equal to 6. It's 36. Okay, how can you get 1/6? It is pretty simple. You need to multiply by 6 here, right? 6, 6, 2, 6, 6, right? And like I said before, 6, 0 is, huh? What? How? Explain to me how. Hmm? Have you got logarithm before? Okay, 616, 62, 36, 63. You need to multiply by 6, right? From here, 62, 36. You go from here to here. It's divide by 6, right? 36 by divide by 6, 6, right? And to get here, divide by 6. So 6 divided by 6 is, okay, good. So if I have this, so this is positive, all positive. This getting negative. So what is this? Okay, got the logic? Okay, please remember that, okay? If not, then your whole calculus will be trouble, or your whole in engineering will be in trouble, okay? Because I cannot repeat all the same concept all over again. Okay? You need to be independent, learn by yourself, okay? Okay, so y is -1, so y is -1, okay? I know not all of you are in the same background, but you need to work harder to achieve the standards, okay? At least this is really basic. This is really the, if you cannot understand the logic behind the exponent and log, uh, it will be difficult. Difficult. Let me just try some exercise. Or who else is still confused on how we solve this? Who else? No, right? You got it right. Okay. Okay. And also for the online students, please check your concept. Okay. Your basic concept of most of the high schools. Okay. But because we are doing basic math now. If you are going forward and maybe because of something you got lucky and passing this exam course, etc., you found another professor, and the professor found that you don't really know about this. Okay, I don't know what will happen. Okay, let's try some. Let's do some exercise. Log 3 9 log 5. After this, we will go to some logarithm law. What is the first one? Yeah, it's 2. Okay. What is the second one? 4. Yeah. What is the last one? Yeah, half. Okay. If you still confused this 3, uh, try to repeat the same process from before, okay, from the previous one. Okay. I will go for the next page is the it's a logarithm law, but I will just say log laws. Okay. Okay. For example, if I have log 5 5, it's 5 1, right? It's 1. Okay. So I can say that if I have just any number a, it will be 1. Okay. This is the first one. And for example, if I have log 5 5 plus log 5 6 to 5, we already did 6 to 5. We can arrange this. This become 1, this become 4, and this become 5, right? Should be. But what will happen is log 5 let me just make smaller so this will be easier. So it will be 4. So 5 5 and 5 125 will be 6 to 5. Okay, we already did before. It's 4. Okay, so we can say that if you have log with the base of a, b, plus log with the base of a, q, it's the same as log with the base of a, b, q. This is for additions. And also for the subtractions, if you have the same log, but you subtract both of them, then you will have log with the base of a, b over q. Okay. Let me move to the other page. um, we have a log a. We can write this as log a. This is p squared. Okay, but we can also write this as, if we just add this, we can also write this like this. Okay, so this notes that this 2 is same as this 2. So if you have for if you have some n number as a constant, you can remove that n and become the index. Okay, so if you have log something with some index, maybe log x squared, then the squared, the 2, you can move to the front. Okay, like this n. Okay, let me write some. Let's say we have let x is equal log a b. Okay, I can rewrite this as a with the power of x is equal b. Okay, let me move b around here, and I can make both of this in log. Let's just add log. Okay, with base of c, we can do that. And from previously, this x can be here, move to the front. Okay, and I can have my x is log. Okay, so I can write this because x is log a b. So log the base of a of b. You can say this is log b over log a. Because in reality, your base will become not really meaningful here, because it is so it's, you can practically you can have c any base you want. You can change it. You can change to base of e, which is the ln, which you can change to any number you want. This c, these two, okay, because you will be canceling each other. So log a b is log b over log a. And you can also have the, let me say this is 5. You can also have log AB is 1 over log BA. Just switch this over. Okay, let me give you some examples and how to solve that. Pretty much that is all the basic rules in logarithms. Okay, some law, some uh, how to calculate, okay? Evaluate, 5 log base of 8. Okay, this and 2 log 3 It's not this. It's here. So the first one is 5 log with a base of 8 of 2. This is half log base of 8 of 4. This is 3 log base 3 of 270. Log base 3 of 2. Log base 3 of 5. Okay, try that one. What is the first one? Yeah, 64. This 64. And number 2? Yeah, 3. Okay, 3. Okay. Okay, I will continue next week or tomorrow and next week for the logarithm. So please read uh, the basics, read the how to solve from the previous slides, okay, and try to solve this by your own, okay. If you still cannot solve this by your own, I don't know how to move forward, okay. Okay, that's it.